On November 27, 1945, Commander Toshikazu Ohmae stood in the cavernous hangar deck of USS Essex, anchored in Tokyo Bay. The war had ended 3 months earlier. Ohmae wore a civilian suit because the Imperial Japanese Navy no longer existed. Around him, American sailors worked methodically, their voices echoing off steel bulkheads that stretched 200 feet in every direction. Ohmae had commanded destroyers during the war. He had survived Leyte Gulf, survived kamikaze duty, survived the final desperate months when Japan's navy existed only to die. Now he was part of a technical inspection team, former enemy officers invited aboard to examine the ships that had destroyed them. The Americans called it educational outreach. Ohmae called it facing the truth. He placed his hand against a structural beam. The weld was perfect. Not good. Perfect. The bead ran straight for 12 feet, without variation, without flaw, without the slight irregularities that showed human hands had made it. Ohmae had inspected Japanese carrier construction at Kure Naval Arsenal before the war. He knew what quality looked like. This wasn't just quality. This was something else. This was industrial precision applied to naval architecture on a scale Japan had never attempted. The beam he touched was one of thousands, every beam identical, every weld identical. Every joint, every plate, every structural member built to specifications so exact that replacement parts could be manufactured anywhere in America and would fit perfectly when they arrived at the shipyard. Ohmae understood ships. He understood construction. He understood metallurgy and engineering. What he was seeing made no sense, according to everything he knew about shipbuilding. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. An American lieutenant noticed Ohmae's interest. That's a primary, structural member, commander. Part of the hangar deck support system. We've got about 4,000 of them in the ship, 4,000 identical beams. Ohmae did the mathematics automatically. If each beam required precise fabrication, precise installation, precise welding, then 4,000 beams meant thousands of hours of skilled labor. Except the lieutenant said something else. We prefabricated them in sections of 12. Took about 6 days to manufacture a complete structural section in the fabrication shop, then another 2 days to install it in the hull. The whole hangar deck structural system was completed in 8 weeks. 8 weeks. Ohmae had watched Unryu-class carriers under construction at Kure. The hangar deck structural system took 6 months. Minimum. Even working around the clock, even with experienced ship fitters who had built carriers for 20 years, 6 months was standard. 8 weeks was impossible. The lieutenant continued. Would you like to see the propulsion spaces? Most visitors find those interesting. They descended 3 decks through passages lined with pipes, cables, ventilation ducts, everything labeled, everything organized, everything positioned with geometric precision. The main machinery room was massive. 4 turbine sets, 8 boilers, reduction gears the size of small houses, all fitted together in a space so carefully designed that every component could be accessed, maintained, or replaced without removing anything else. Ohmae had served in engine rooms. He knew the reality. Equipment broke down, pipes leaked, bearings failed. When that happened, crews spent days or weeks disassembling surrounding equipment just to reach the failed component. This machinery room had maintenance access built into every system. Removable deck plates positioned over critical equipment, overhead rails for lifting heavy components, tool storage integrated into the bulkheads. The difference wasn't subtle, it was fundamental. Japanese. Carriers were built by craftsmen who custom-fitted each piece. American carriers were built by engineers who designed systems for mass production and lifetime maintenance. Ohmae asked the question that had troubled him since boarding. How long did it take to build this ship? The lieutenant checked a clipboard. Essex was laid down April 28, 1941, launched July 31, 1942, commissioned December 31, 1942. 20 months from keel laying to commissioning. 20 months. Taiho, Japan's finest carrier, had taken 32 months. Unryu-class carriers, smaller and simpler, took 28 months. The Americans had built a larger, more capable carrier in less time than Japan's fastest construction program. The lieutenant added casually, "Of course we got faster as we went." Later, Essex-class ships were averaging 16 months. Hancock took 14 months. Some of the crew jokes that we were building them faster than we could name them. Ohmae said nothing. There was nothing to say. The numbers spoke for themselves. But numbers were abstract. Standing inside Essex, touching the steel, seeing the systems, understanding how everything fit together, that made the numbers real. This wasn't just a ship. This was proof of industrial capacity so far beyond Japan's capabilities that comparison became meaningless. The inspection team spent 6 hours aboard Essex. They examined flight deck operations, aircraft elevators, radar systems, damage control equipment, crew accommodations, magazines, workshops, everything the Americans would allow them to see. Each system revealed the same pattern: standardization, prefabrication, mass production techniques applied to naval architecture. The aircraft elevators were hydraulically powered, capable of lifting 30-ton aircraft from hangar deck to flight deck in 30 seconds. Japanese carriers used electric elevators that took 90 seconds and frequently failed under combat stress. Essex had 3 elevators, all identical, all built in the same factory, tested before installation, and fitted into the carrier hull as complete assemblies. The radar systems covered every approach vector. Air search radar could detect incoming aircraft at 90 miles. Height-finding radar could determine altitude. Surface search radar could track ships at 40 miles. Fire control radar could direct anti-aircraft guns automatically. Japanese carriers had basic air search radar that worked intermittently and required constant adjustment. The damage control systems were comprehensive. Fire mains with pumps that could deliver thousands of gallons per minute, foam generators for fuel fires, portable pumps staged throughout the ship, watertight doors that could be closed from the bridge, damage control parties trained to fight fires, control flooding, and repair battle damage while under attack. Japanese carrier damage control relied on crew discipline and basic equipment. When Taiho was hit by a single torpedo in June 1944, poor damage control decisions turned manageable damage into catastrophic loss. Essex had been hit by kamikazes multiple times. She survived because her damage control systems worked. The crew accommodations startled Ohmae more than the technical systems. Enlisted men slept in bunks with mattresses, pillows, and clean sheets. The berthing compartments had ventilation, lighting, and enough space for men to move without climbing over equipment. Japanese carriers packed crew into spaces barely large enough to lie down. Men slept on mats between machinery, in passages, anywhere there was room. The American philosophy was different. Comfortable crew performed better. Rested crew made fewer mistakes. Well-fed crew stayed healthy. Essex had cafeterias that served hot meals 3 times daily. Japanese carriers rationed food. By 1944, carrier crews were surviving on rice and dried fish. But the real revelation came in the workshops. Essex had machine shops, equipped with lathes, drill presses, milling machines, welding equipment, everything needed to manufacture replacement parts at sea. If a component failed, machinists could fabricate a new one without waiting for resupply. Japanese carriers had basic tool sets. If something broke, they made temporary repairs and hoped it held until they reached port. The American carrier was designed for sustained operations far from base. 6 months at sea, 8 months. However long the mission required, the ship carried fuel, ammunition, spare parts, food, everything needed for extended deployment. When supplies ran low, replenishment ships transferred material while underway. The Japanese had attempted underway replenishment, but never mastered it. Their carriers returned to port regularly because they lacked the logistics systems to sustain operations. Ohmae stood on the flight deck as the inspection concluded. The deck stretched 150 feet, 108 feet wide, armoured with 3.5 inches of steel plate. Aircraft could land, taxi forward, be struck below on elevators, while other aircraft launched from the bow. The cycle could continue indefinitely. Launch, recover, rearm, refuel, launch again. Japanese carriers had wooden flight decks, lighter but vulnerable to fire and battle damage. Armoured flight decks were heavier, required stronger structural support, demanded more sophisticated engineering. The Americans built them anyway because armoured decks saved ships. The other members of the inspection team gathered near the island superstructure. Captain Rikihei Inaguchi had commanded carrier Junyo before her loss. Commander Masatake Okumiya had served in carrier air groups throughout the war. Lieutenant Commander Sadamu Sanagi had been a flight operations officer aboard Shokaku. All veterans, all experienced carrier officers, all looking at Essex with the same expression Ohmae felt on his own face. Understanding. Terrible, complete understanding of why they had lost. Captain Inaguchi spoke first. They built 24 of these. Not a question. A statement. Okumiya nodded. 24 Essex-class fleet carriers, 9 Independence-class light carriers, 77 Casablanca-class escort carriers. We counted over 100 American carriers by war's end, Sanagi added quietly. We built 9 carriers during the war. 3 Unryu-class, 3 converted light carriers, 3 escort conversions, 9 carriers in 3.5 years. The numbers had been abstracts in intelligence reports. Now they were real. Standing on Essex's flight deck, understanding the engineering that went into her construction, knowing that 23 more ships exactly like this one existed, and knowing that American shipyards had built them all in less time than it took Japan to build a single Taiho, the scope of Japan's defeat became impossible to ignore. The Americans hadn't just outproduced Japan. They had operated on a different level of industrial capability entirely. Ohmae thought about the welding he had seen in the hangar deck. Perfect welds. Thousands of them. Tens of thousands. All identical. All completed by workers who had learned to weld in 2-week training courses. Kaiser Shipyards in Richmond, California, had employed 90,000 workers at peak production. 90,000. That was more workers than all of Japan's major naval shipyards combined. And most of Kaiser's workers were women who had never seen a ship before 1941. They learned to weld, learned to read blueprints, learned to operate cranes, and within months they were building ships faster than experienced Japanese shipwrights could imagine. The American industrial system was designed around a principle Japan had never fully embraced: interchangeable parts, standardization, mass production. An Essex-class carrier wasn't built by craftsmen custom-fitting each piece. It was assembled from prefabricated modules manufactured in factories across America. A bulkhead section built in Pennsylvania was identical to one built in California. Either would fit perfectly in any Essex-class carrier under construction. That approach required precision manufacturing, tight tolerances, and quality control systems that Japanese industry lacked. Ohmae had visited Japanese aircraft factories before the war. He had watched skilled workers hand-fitting each component of Zero fighters. The craftsmanship was extraordinary. Each aircraft was slightly different because human hands made small variations. Those variations meant mechanics had to adjust every repair, customize every replacement part, treat each aircraft as unique. The American approach was opposite. Build everything identical. Any part fits any aircraft. Mechanics didn't adjust. They replaced. Faster, simpler, requiring less skill. When Japan lost experienced aircraft mechanics in combat, replacements struggled, because the work required expertise. When America lost mechanics, replacements learned basic procedures in weeks because the systems were designed for minimal training. The same philosophy extended to carriers. Essex's machinery spaces used standardized components: pumps, valves, gauges, switches, all identical across the entire Essex class. A sailor trained on one ship could serve on any other ship without retraining. Supply chains simplified because every ship needed the same parts. Maintenance streamlined because procedures were identical. Japanese carriers were individual designs. Akagi differed from Kaga, Soryu differed from Hairyu, Shokaku differed from Zuikaku. Each required specialized training. Each needed unique spare parts. Each demanded expertise that took years to develop. When Japan lost experienced carrier sailors at Midway, at Philippine Sea, at Leyte Gulf, they lost irreplaceable knowledge. The Americans could lose an entire carrier crew and replace them with sailors, transferred from other carriers who already knew the systems. That resilience, that ability to absorb losses and continue operating, came from industrial standardization applied systematically across naval construction. Ohmae watched American sailors working on the flight deck. They moved efficiently, each man knowing his job, working in teams that functioned like machinery. These weren't the veteran sailors who had started the war. Those men were dead, reassigned, promoted to training commands. These were replacements. Kids from farms and cities who had joined the Navy in 1943 or 1944. They had perhaps 18 months of service. Yet they operated this complex ship competently because the training systems worked and the ship systems were designed for rapid crew integration. Japanese carrier crews required years to achieve proficiency. By 1944, Japan didn't have years. Pilots graduated to fleet squadrons after 6 months of training, instead of 2 years. Sailors joined carrier crews after 3 months of basic training instead of 12 months. Aircraft mechanics learned their trade in weeks instead of years. The abbreviated training showed in combat effectiveness. At Philippine Sea, American fighters destroyed 300 Japanese aircraft in a single day. The pilots flying those aircraft were brave. They were dedicated. They were willing to die for Japan. But they weren't ready. They couldn't survive against veteran American pilots flying superior aircraft from carriers like Essex. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The inspection team left Essex as evening settled over Tokyo Bay. They rowed a launch back to shore in silence. What was there to say? They had seen the truth. Japan lost the Pacific War because American industrial capacity exceeded Japanese capacity by ratios that made conventional warfare impossible. Every carrier Japan built required steel, aluminum, copper, rubber, electronics, all transported by merchant ships that were being sunk by American submarines. By 1944, Japan's merchant fleet was destroyed. Critical materials weren't arriving at shipyards. Construction programs delayed because workers waited for steel plate, turbine blades, electrical cable, American shipyards received materials by rail and truck from factories across the continent. If one supplier had problems, alternatives existed. Supply chains were redundant, robust, effectively infinite. Ohmae had known intellectually that America was larger than Japan. Everyone knew. Geography wasn't secret. But understanding America's size and understanding what that size meant for industrial production were different things. America had 10 times Japan's population. America produced 10 times more steel. America had 10 times more machine tools. Those ratios translated directly into military capability. 10 times more ships, 10 times more aircraft, 10 times more tanks, trucks, guns, ammunition, everything. Japan couldn't win a war of production. Yamamoto had said so before Pearl Harbor. He warned the government that Japan could win battles for 6 months, perhaps a year. After that, American industry would overwhelm anything Japan produced. The government ignored him. They believed spirit could defeat steel. They were wrong. Spirit mattered, courage mattered, tactical skill mattered. But they mattered less than factories, shipyards, and assembly lines that operated 24 hours daily, producing weapons in quantities that seemed impossible. Ohmae thought about the workers he had seen during the inspection. Young men, most looking barely 20 years old. They maintained Essex's systems competently, confidently, without apparent supervision. Japanese carriers required experienced petty officers watching every task, because one mistake could cripple critical systems. Essex's systems were designed so that mistakes were difficult. Color-coded pipes indicated contents, labeled valves showed function. Instructions posted at every station. The ship itself taught crew how to operate it. That design philosophy extended to combat systems. Essex's anti-aircraft guns were radar-directed. Fire control computers calculated trajectories automatically. Gunners aimed where the computer indicated and fired. Japanese anti-aircraft guns relied on manual sighting. Gunners estimated range, estimated speed, estimated trajectory, and fired hoping they calculated correctly. The American system was faster, more accurate, and required less training. The radar systems were equally sophisticated. Essex had multiple radar sets providing overlapping coverage. If one set failed, others compensated. Operators received clear displays showing range, bearing, altitude of every contact. Japanese radar operators struggled with equipment that provided ambiguous information requiring interpretation. Everything about Essex reflected systematic thinking about how to build, operate, and maintain a warship using principles of mass production, standardization, and simplification. The ship wasn't just powerful, it was efficiently powerful. Every system optimized for maximum effectiveness with minimum training. Every component designed for rapid replacement. Every procedure streamlined for speed. The result was a carrier that could be built in 16 months, crewed by sailors with 18 months of experience, and operated effectively in sustained combat operations for months without returning to base. Japan couldn't replicate that capability. Japanese industry lacked the precision manufacturing base for mass production. Japanese shipyards lacked the construction techniques for rapid building. Japanese training systems lacked the time for proper crew preparation. By mid-war, every advantage Japan possessed at Pearl Harbor had evaporated, and American advantages had compounded. That night, Ohmae couldn't sleep. He sat in the small room assigned to the inspection team, writing notes by lamplight. His observations filled page after page. Welding techniques, structural design, prefabrication methods, standardization protocols, everything he had seen aboard Essex, everything that explained Japan's defeat. But the technical details weren't what kept him awake. It was the realization that Japan had never understood what they were fighting. The Imperial Japanese Navy entered the war believing carrier aviation was an art form. Pilots trained for years to master their craft. Carriers were built by master shipwrights who spent decades perfecting their skills. Each ship was unique, a testament to Japanese engineering excellence. The philosophy emphasized quality over quantity. One perfect carrier was worth more than 3 adequate carriers. One superbly trained pilot could defeat 5 average pilots. The Americans proved that philosophy wrong. They treated carrier aviation as industrial production. Build adequate carriers in vast numbers. Train adequate pilots quickly using standardized methods. Overwhelm the enemy through sheer volume. Quality mattered less than quantity when quantity reached certain thresholds. 3 adequate carriers could sink 1 perfect carrier through concentrated attack. 5 average pilots could kill 1 superb pilot through numerical superiority. Japan lost because they fought an industrial war using artisan methods. The Americans understood that modern warfare required modern industrial processes. Henry Kaiser, the dam builder who revolutionized ship construction, had never built a ship before 1941. That lack of experience became his advantage. He wasn't constrained by traditional shipbuilding methods. He looked at ships as structures that could be assembled from prefabricated components, and he applied construction techniques from dam building to naval architecture. Traditional shipbuilders said it was impossible. Kaiser built 50 escort carriers in 14 months, proving them wrong. Newport News Shipbuilding, which constructed most Essex-class carriers, learned from Kaiser's innovations. They developed specialized fabrication facilities where components were built in optimal working conditions, then transported to the shipway for final assembly. A flight deck section wasn't built in place by workers balancing on scaffolding. It was built in a climate-controlled factory building, positioned for easy welding access, completed with all equipment installed, then lifted by cranes and set into position on the carrier hull. The entire flight deck of an Essex-class carrier was assembled from prefabricated sections in weeks rather than months. Ohmae had watched Japanese shipyards struggle with flight deck construction. Workers built each section in place, climbing, scaffolding, working in uncomfortable positions, welding overhead, fitting pieces that required constant adjustment. It was skilled work, demanding work, slow work. The Americans eliminated most of that difficulty through prefabrication. Workers built components in comfortable positions, using jigs and fixtures that held everything perfectly aligned. Speed increased, quality improved, training time decreased. The Americans had systematized excellence. The morning after the inspection, the team met with American naval officers for a debriefing session. Captain Edmund McSweeney, who had commanded Essex during the Marianas Campaign, answered questions with surprising candor. The war was over. Secrecy no longer mattered. Captain Inaguchi asked the question all of them wanted answered. "How did you build so many carriers so quickly?" McSweeney smiled. "We cheated. We used prefabrication, standardization, and mass production techniques that naval architects said wouldn't work for carriers. We proved them wrong by building ships faster than they said was possible." He explained that Essex-class carriers weren't individually designed. Every ship used identical plans. That standardization meant lessons learned on one ship applied to all ships. If engineers discovered a better way to install a radar mast on Essex, every subsequent carrier incorporated that improvement. Design refinements accumulated across the entire class. By the time Hancock was built, the 20th Essex-class carrier, construction techniques had evolved significantly. Workers knew exactly how to build each section efficiently. Supply chains delivered materials in perfect sequence. Assembly progressed like clockwork. McSweeney continued, We also accepted that good enough was acceptable. Japanese carriers were beautifully built. I've seen photographs of Taiho's interior spaces. The finish work was extraordinary. Essex has exposed pipes, visible cable runs, bare steel in crew spaces. We didn't waste time making things pretty. We focused on making them functional. That philosophy saved months of construction, time per ship. The comment stung Ohmae because it was accurate. Japanese carriers emphasized craftsmanship, polished wood in officer quarters, carefully fitted joints in visible spaces, attention to aesthetic details that served no combat function. The Americans built warships designed exclusively for fighting. If something didn't contribute to combat effectiveness, they eliminated it. Commander Okumiya asked about crew training. Your sailors seemed very young, yet they operated complex systems competently. How long do they train? McSweeney consulted a folder. Basic training is 8 weeks. Technical training for specialized ratings varies from 8 weeks to 6 months. Most sailors aboard Essex have less than 2 years of service. We lost experienced crew at Midway and Coral Sea. The Navy rebuilt using rapid training programs focused on specific jobs rather than general seamanship. 2 years. Japanese carrier sailors trained for 5 years before being considered fully qualified. The Americans condensed training by narrowing focus. A sailor didn't need to understand the entire ship. He needed to understand his specific station, his specific duties, his specific procedures. Specialization allowed rapid training. The same principle applied to pilots. Before the war, Japanese naval aviators trained for 2 years. They learned navigation, gunnery, formation flying, carrier operations, night flying, instrument flying, everything. By 1943, American pilot training programs were graduating combat-ready pilots in 9 months, using standardized curricula and abundant training aircraft. The Americans lost pilots in combat and replaced them with new graduates who flew adequately. Japan lost pilots in combat and couldn't replace them because training programs couldn't keep pace with losses. By 1944, veteran Japanese pilots were flying with wingmen who had 50 hours of flight time. Those inexperienced pilots died quickly against American fighter sweeps, and their deaths accelerated the decline of Japanese carrier aviation. The statistical reality was brutal. At Philippine Sea in June 1944, American fighters shot down 300 Japanese aircraft while losing 29 of their own, exchange ratio of 10-1. That ratio reflected superior American aircraft, but more importantly, it reflected superior training systems that produced competent pilots in quantity. Lieutenant Commander Sanagi asked about damage control. Essex was hit by kamikazes multiple times but survived. How? McSweeney's expression grew somber. Damage control won more battles than gunfire. We designed carriers to survive hits, armored flight decks, redundant systems, comprehensive firefighting equipment, but mostly we trained crew obsessively. Every sailor knew damage control procedures. We conducted drills weekly. When kamikazes hit, crew responded automatically. They fought fires, controlled flooding, maintained propulsion, kept the ship fighting. He described Essex's experience off Okinawa. A kamikaze penetrated the flight deck, exploded in the hangar, started massive fires, fuel ignited. Ammunition cooked off. The ship seemed doomed, but damage control teams fought through smoke and flames, cooling magazines before they exploded, containing fires to prevent spread, maintaining steam to vital systems. 3 hours after impact, Essex was recovering aircraft. Japanese carriers hit by similar attacks usually sank. Taiho, Shokaku, Hio, all lost to single torpedo hits that triggered catastrophic secondary damage. The difference was damage control, doctrine, and equipment. American carriers were designed to take punishment and continue fighting. Japanese carriers were designed to avoid being hit. The debriefing lasted 4 hours. When it concluded, Captain Inoguchi thanked the American officers formally. "You have taught us much. We believed carrier warfare was an art requiring decades to master. You proved it was engineering and industrial production. We lost the war because we misunderstood what we were fighting." McSweeney responded quietly. "You fought bravely. Your pilots at Philippine Sea pressed attacks against overwhelming odds. Your sailors at Leyte Gulf sailed into battles they knew they couldn't win. Courage wasn't the difference. Industrial capacity was the difference. We had more ships, more aircraft, more everything. Eventually, numbers overwhelm courage." The team returned to their quarters. Over the following weeks, they visited other captured Japanese installations, examined other American ships, and compiled comprehensive reports on why Japan lost the naval war. The reports documented technical details, but Ohmae understood the deeper truth. Japan lost because they entered an industrial war with a feudal military philosophy. The Imperial Japanese Navy emphasized warrior spirit, martial tradition, individual excellence. Those values had merit, but they couldn't compete against assembly lines producing carriers monthly, training programs graduating pilots weekly, and logistics systems that kept fleets operating indefinitely at sea. Admiral Isoroku Yamamoto had warned before Pearl Harbor that Japan could win battles for 6 months, then American industry would overwhelm them. He was precisely correct. Japan won every major engagement through June 1942. Then came Midway. 4 carriers lost in 6 minutes. The turning point wasn't tactical. It was mathematical. Japan couldn't replace 4 carriers quickly enough to maintain numerical parity. America could replace 4 carriers and build 8 more. The gap widened exponentially from that moment. Ohmae thought about the pilots he had known. Saburo Sakai, one of Japan's greatest aces, survived the war with 64 confirmed kills. Sakai told Ohmae about training programs in 1943. Instructors were told to rush students through. Forget advanced techniques. Teach them to fly and shoot. Send them to fleet squadrons immediately. The pilots who graduated from those abbreviated programs were brave boys, but they weren't ready. They died in their first combat encounters against American fighters flown by veterans with 200 combat hours. Each death reduced Japan's combat effectiveness further. Each death was irreplaceable because training pipelines couldn't produce qualified replacements fast enough. The Americans lost pilots too, but their training systems produced replacements faster than combat consumed them. By 1944, American carrier air groups had more pilots than aircraft. Japan had more aircraft than pilots. The inversion was complete. In December 1941, Japan possessed the world's finest naval aviators. By December 1944, American naval aviators were qualitatively and quantitatively superior. 3 years. That's how long it took American training systems to surpass 20 years of Japanese development. The same pattern repeated across every military specialty. Radar operators, damage control technicians, aircraft mechanics, fire control specialists, every technical rating required trained personnel. American training systems produced them in quantity. Japanese training systems struggled to replace losses. By war's end, American carriers operated at full capability. Japanese carriers, the few that remained, operated at reduced capability because they lacked qualified crew. Ohmae spent months analyzing the data. His final report to the disbanded Naval Ministry concluded with a paragraph that summarized everything. The Imperial Japanese Navy lost the Pacific War before the first shot was fired. We entered conflict with an industrial power 10 times larger than Japan. We believed spirit, courage, and tactical excellence could overcome that disparity. We were wrong. Modern naval warfare is industrial warfare. Victory requires factories, shipyards, steel mills, training facilities, and logistics networks operating at scales we could never achieve. America possessed those capabilities. Japan did not. The outcome was inevitable. The report was filed in archives that few people read. Japan was occupied, devastated, rebuilding from rubble. The Navy no longer existed. Carrier aviation was forbidden under occupation terms. The lessons Ohmae documented seemed irrelevant to a nation focused on survival. But decades later, those lessons would prove prescient. Japan rebuilt using the same principles that had defeated them: standardization, mass production, quality control, continuous improvement. Japanese industry adopted American manufacturing techniques, refined them, and eventually surpassed American productivity in many sectors. The irony wasn't lost on Ohmae. Japan lost the war because they rejected industrial mass production. They won the peace by embracing it. In 1945, standing aboard Essex, Ohmae understood that Japan had fought the wrong war using wrong methods against a wrong enemy. The Imperial Navy prepared to fight battleship duels in decisive engagements where superior Japanese fighting spirit would prevail. Instead, they faced carrier task forces supported by industrial production systems that treated warships as manufactured goods to be built in quantity, operated by adequately trained personnel, and replaced when lost. The Americans didn't need superior warriors. They needed adequate workers organized efficiently. Essex proved that philosophy worked. Years after the war, Ohmae met Admiral Raymond Spruance, who commanded the Fifth Fleet at Philippine Sea. They discussed the battle that destroyed Japanese carrier aviation. Spruance said something that stayed with Ohmae forever. "We didn't outfight you. We outproduced you. Every carrier you lost was irreplaceable. Every carrier we lost was replaced within months. That difference, more than any admiral's skill, determined the war's outcome." Spruance was being modest. American admirals demonstrated considerable skill, but his essential point was correct. Industrial capacity was the dominant factor in naval warfare. Japan's finest admirals, brilliant tacticians like Yamamoto and Ozawa, couldn't overcome 10-to-1 production ratios. No amount of tactical genius could defeat 50 American carriers with 5 Japanese carriers. Mathematics was destiny. The human cost of that mathematical destiny was staggering. Japanese carrier aircrews suffered 90% casualties by war's end. Pilots, bombardiers, radiomen, gunners, all dead. Not because they lacked courage or skill, but because they faced impossible odds. American carrier aircrews suffered 30% casualties, heavy by any measure, but survivable for the aviation program as a whole. The difference reflected industrial capacity, translating into combat power. Ohmae attended memorial services for fallen comrades after the war. He stood in silent tribute to pilots, who flew from carriers that no longer existed, fighting for a nation that had ceased to exist, dying in battles whose outcomes were predetermined by shipyard production schedules determined years earlier. Their sacrifice wasn't meaningless, but it was tragic. They fought with extraordinary courage against systemic disadvantages that courage couldn't overcome. The inspection of Essex marked the moment when theoretical understanding became visceral knowledge. Intelligence reports had documented American carrier production. Everyone knew the numbers. But standing inside Essex, touching the steel, seeing the systems, understanding the engineering philosophy, The abstraction became concrete reality. Japan never had a chance. Not because Japanese sailors lacked courage, not because Japanese engineers lacked skill, but because American industrial capacity operated on a scale Japan couldn't approach even theoretically. The final irony was that Japan created the model they eventually fought against. In the 1920s and 1930s, the Imperial Japanese Navy studied American industrial production. They sent officers to tour American factories. They documented American shipbuilding techniques. They understood American capabilities. Then they attacked anyway, believing that initial tactical victories would force American acceptance of Japanese territorial gains. They assumed America would negotiate rather than mobilize for total war. That assumption was catastrophically wrong. America mobilized completely, and Japanese leaders discovered too late that American industrial capacity exceeded their worst estimates. Essex represented the physical manifestation of that miscalculation. One ship among 24 identical ships, all built in less time than Japan, took to build 3 smaller carriers. Each Essex-class carrier displaced 27,000 tons, carried 90 aircraft, could make 33 knots, had comprehensive radar, had effective damage control, could operate independently for months. Japan never built a carrier matching Essex's capabilities, and the Americans built 24 of them. Walking off Essex for the final time, Ohmae paused at the gangway. He looked back at the massive ship, quiet now in peacetime, its flight deck empty of the aircraft that once launched against Japanese positions. This ship had fought at Philippine Sea. It had fought at Leyte Gulf. It had fought off Okinawa. It survived the war and would serve for decades afterward. Taiho, Japan's equivalent, lasted 3 months. The comparison was complete. The sun set over Tokyo Bay as Ohmae returned to shore. The war was over. Japan was defeated. The Imperial Navy was dissolved. But the lessons remained. Industrial capacity determined modern warfare outcomes. Mass production defeated craftsmanship. Adequate quantity overwhelmed superior quality. Those lessons, learned aboard Essex in the aftermath of total defeat, would guide Japan's reconstruction, eventual return to prosperity. The nation that lost the war by rejecting industrial mass production would win the peace by mastering it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.